Alright, we're back. Sorry. Listening. Just, I don't know why. Must be the heat. It's overheating. But here we go. In order to add, you need the positions to be exactly the same. So I'm just saying row 1, column 1. Add these two together. 4 plus negative 1. And if you can see, 4 plus negative 1 gives you 3. And you write out, so each position will give you the value. So you can see I will do 1 plus 4. And it'll be 1 plus 4, which that tells me 5. Okay, and then same thing with 3. 3 plus 3 gives you 6. And that gives you the addition of matrices. And that's what you're doing, position by position. Okay, that's what I'm saying. When you're doing exercise 2E, addition and subtraction will be easy. Okay, so don't bother doing them all. It's a waste of time. If you understood, you remembered it, move on. Okay, now multiplication. I said when you multiply, it's row 1 by column 1. Yeah? So this is my row 1. So that's my row 1 multiplied to column 1. Okay, now it's going to be like a distributive law. It's going to be row 1, column 1, column 2 with row 2. That's what you're really doing there. So if you can see, what I'm going to do is, this is a 2 by 2 matrix. That's a 2 by 3. Column of the first one is equivalent to the row of the second. So these two are the same, so you can multiply them. Here we go. We're going to multiply those two together. And here's what I have. 2 times the negative 2, which is here, plus with 4 times the 4. Row 1, column 1. And that answer will go to row 1, column 1 as well. Okay, so think about it. This is going to be, if you didn't know the trick as well, the final answer will be a 2 by 3 matrix. So this final step here, these two will tell you what your final matrix should be. So it's going to be a 2 by 3. So see, if I want to find the next column, so this is row 1, column 1. This will be row 1, column 2. And how do you get that? That would be 2 by 4. So I'm just going to rub this off. It's going to be 2 by 4 multiplied to column 2. So row 1, column 2. That will give you the answer for row 1, column 2. Okay, so 2 by negative 1, that's what I wrote here. 2 by negative 1. And then 4 multiplied to 3. So 4 multiplied to the 3. You can see that's 4 plus 3. That's what you're getting there. 4 times 3 plus row 1, column 2. If you want to get column 3, it'll be row 1, column 3. So same thing again. Row 1 is 2 and 4. Multiplied to column 3. So you can see it'll be 2 times the 2, which is here. And then 4 times the negative 1, which then add those two together. That's how you multiply. Okay, so I want you to practice that. Make sure exercise 2E. Exercise 2E, that's how you're doing your multiplication. You've got to practice that so you remember how to multiply matrices. But here we go. If you do that all together correctly, you get negative 4 plus 16. So that gives you 12. And you get negative 2 plus 12 gives you 10. So that's how I'm getting all my positions. And notice, this ends up being a row, two rows by 3 columns. That's why you can tell if these two are the same, you can multiply, and your ending result would be a 2 by 3. Okay? Any questions on the multiplication for matrices? Because that's the basic stuff that you need to know first. Addition, subtraction, multiplication. Let's try another one. Just for the sake of practicing, I want you to multiply. You don't need to do it here in this particular example, but I want you to try for me A times B. Okay, so I want you to find me what A, matrix A multiplied to matrix B would give me. So I'm saying 3, negative 1, 2, 1. I want you to multiply this to 0, negative 4, negative 2, 8. Okay? So using what I just showed you, what would my end result be? This is a 2 by 2 matrix. And this is a 2 by 2 matrix. What would my ending matrix have to look like? 2 by 2. Okay, so if these two are the same, the ending result will be 2 by 2. Okay, so as long as you get a 2 by 2 matrix, you're probably on the right track. Okay? Please multiply this. Let's go. So each one, I want to get a result for each of these 4. Now you don't need to do it for this question, I'm just practicing your multiplication of matrices. All right, let's go through the answer. Row 1, column 1. What should my value be, Percy? Yep. -4 is correct. Again, 3 times 0 is 0, plus 2 times -2 is -4. 0 minus 4 is -4. Good. What's the next position? Row 1, column 2. What's my value, Amy? Row 1, column 2. I want to know what my value would be if I expanded this. What would it be? Wait, did I call out the right person? Amy? So I'm asking you to expand, multiply these two. I want to know what row 1, column 2 is equal to. Just 4, correct. Okay, and again, same thing. 3 times -4, -12. 2 times 8 is 16. Positive 16 minus 12 gives you 4. Okay? Sebi, what'd you get for row 2, column 1? -2 is correct. And then finally, row 2, column 2, Luke? 4, yes, you're right, 12. Okay, good, excellent. So we can multiply. Now, this particular question says matrix A is 3, 2, -1, 1. Then you got matrix B, which is 0, -4, -2, 8. They say find the matrix X, which is this one here. We want to know what X has to equal to if this is the equation. The equation says twice matrix A plus matrix X should give me matrix B. Now this is simple because this is very similar to your linear equations. If you want to find X, remember in matrices you can add, subtract, multiply. You can't divide. You can add, subtract, multiply. So in this case here, if I want to find what X is, I can say subtract 2 times the matrix on both sides. See how I'm doing that? I'm just balancing the equation. So 2A minus 2A is going to cancel out to be 0. And so you're left with X is equivalent to B, subtract twice matrix A. So if I wrote this out, matrix X has to equal to B, which I know is 0, -4, -2, 8, minus 2 multiplied to 3, 2, -1, 1. Now, that 2 is a constant. Because it's a constant, that means you can double every term inside. That's okay. It's a scalar product. Okay? So if you expand this, this now becomes 0, -4, -2, 8. And this can now become add -6, -4, +2, -2. See what I'm doing there? Okay, so I multiplied the -2 to the 3, -2 to the 2, -2 to the -1, -2 to the 1. Or if you want to keep the minus sign there, just times 2 to each one. It's the same thing. Okay, and then addition, subtraction. Same positions, the 2 by 2, 2 by 2. You add it, and you get your answer for X. So in our case here, the answer would be -6, -8, 0, and 6. Is that easy? Cool? No? Yes? All right. Excellent. Now, that's the basics. What I want to move on to today is what's important. So I said inverses. You've got to learn your matrix multiplication. Now your inverses. Let's have a look at inverses, okay? These are the notes I want you to copy to understand inverses. There's no division with matrices. So, when solving matrices, we know that we can't divide a matrix. So how do we do it? If you had 2x, for example, how do we solve it? So let's have a look at this one. A times x, matrix A times matrix x plus b will give you a matrix C. Now we're using linear equations. What you would say is you say minus matrix B on both sides. That works out, so that cancels out. And then you're left with AX, or A, matrix A times X equals C minus B. But I told you there is no division of matrices, so how do you remove, if this is A times X, traditionally, what you would have done is you say divide A on both sides. But we don't have a division for matrices, so this is a problem. So we're now stuck with AX. We only got, we only got the following. We only got add, subtract, and multiply. And so because of this, if you add and subtract, you're just going to move it left and right. So that means you need to multiply this somehow such that you remove the A. So you think about it, it's like saying, if we're going back to numbers, 3x equals to 4, for example. The only way to remove the 3 is if I can multiply it by a third. Because a third times 3 becomes 1. 1 times x gives me 1x equals 4. So I didn't use any divisions there. I just used times by a third. So this is the concept that what inverse really is. The inverse is saying multiply by something so that it becomes 1. That's what you're trying to do. You're trying to multiply by something to give you 1. And what is that? Last year what you learnt is this I matrix. This I matrix is called the identity matrix. This is identity. Okay, so this identity matrix is saying whatever this number is, you multiply to A, it actually is A. Okay, so what happens is it acts like a 1. That's what you want. You want it to cancel out to be a 1. That's the goal. Okay, so the question is, how do you get the identity matrix? This is what the identity matrix is. If you got this 1, 0, 0, 1 and you multiply to any matrix, let's do A, B, C, D, you'll find that if you did the row 1, column 1, this will still equal to A, B, C, D. Okay, so if you try it, 1 times A, which is A, plus 0 times C, which is still 0, so 1 times A is A. If you tried 1 times B, that's B, plus 0 times D is 0, so that's B. If you did the same thing, 0 times A is 0, plus C, and then 0 times B, which is 0, and 1 times D is D. So what you can see is this identity matrix, multiplied to any matrix, will go itself. The question is, how do you get that? Because that's what I want. What I want is, if I've got AX equals to C minus B, what I want is I want to multiply it by something, well, I'll call it D. I want to multiply it by something on both sides. Okay, I want to multiply by something on both sides such that these two will cancel out to be I. That's what you want. And this is the whole process of what inverse operations or inverse matrix really is doing. Your goal is to find out this number or this matrix so that when you multiply those two, it gives you identity. Why do you want identity? Because identity times X is X. So this is your goal. You're trying to find out this. And this is what we call the inverse matrix. Okay, so that's the logic. The logic is you can't divide, and so what was the only thing you can do? You can only multiply. So what do you multiply to? And you got a formula for this one. I want you to copy this formula down for now, and then I'll show you what it equals to at the end. We want something times an inverse to give you the identity matrix. The formula for the identity matrix is this. You're going to have to memorize this, okay? So how do you find the inverse? The inverse of A, which if you multiply those two, they'll give you the identity matrix. This is it. 1 over AD minus BC. What's AD minus BC again? The determinant. This is the determinant of A. multiplied to, and actually that's wrong, that should be dA. Sorry, fix that, that should be dA, switch the positions. dA minus B minus C. Okay, and I'll show you the last slide of this PowerPoint will show you the proof, and the proof is important because it tells you why all of this works. Okay, and I'm going to try to briefly tell you when we get to the next few slides, but this is the key part. You're either going to memorize all this, and you're going to find troubles answering matrix questions, or you'll listen for a bit and you'll try to understand it, and it will all make sense. Literally, it goes back to Year 9 mathematics, 2 straight lines. That's how simple it is, 2 straight lines. Okay? All right, copy that. Make sure to copy the inverse matrix, and then I'll show you how we do them. Okay, so this is an example of how to use the inverse matrix. So let's say this. You've got matrix A. You got matrix A times another matrix gives you 5, 6, 7, 2. Your goal is to find out what matrix X is. So how do you do it? Your goal is to remove this A. Now the only way that we can remove it is we times. Now remember, it does matter where you times it, because A times B does not equal to B times A. So it actually matters whether you times A on the left or A on the right. So we know that if I multiplied the right-hand side, or the left-hand side, to the right-hand side, if I multiply these two, that should give me the identity matrix. So since I'm multiplying it on the left, see how I'm doing it? I'm multiplying to the left-hand side of this, then it's on the left-hand side on the right-hand side. So what I'm doing there, so it's left-hand side of the matrix. The question is, what is A inverse? Because if I can find that out, these two will cancel out, and you will get X equals to A inverse times 5, 6, 7, 2. Now this is a very key step here. Notice what I just said. I said, if A inverse exists, I will find X. That's literally the whole process of this inverse operation thing. It comes right here. If A inverse, I'm going to write it down so you remember what I'm just saying. If A inverse exists, then matrix X exists. And this is very key. This is where I'm going to go into the theory next. The question is, what does it mean when we say A inverse exists, and why do we want X to exist? Once you get your head around these two, it's very easy. Okay? So, in terms of doing this, this is pretty easy. We're going to find A inverse by using your formula. This was your formula. 1 over determinant of A, which is AD minus BC. So AD minus BC. And you switch these. This is your formula that you had. This is A. So if I switch D and A, it becomes 6, 3. See, this is your D, and that's your A. B was 2 and 1, so then it becomes -2, -1. Simple, yeah? 18, where did I get that? A times D. 6 times 3 is 18. So I've got 18. And B times C is 2 times 1 is 2. So here's my inverse matrix. And then now I'll just put it all back in to solve for X. Okay, and you can multiply this using column 1, row 1, column 1, and you simplify it down, and you get your answers 1, 2, 1, 0. Okay? Now, this is just the mathematics, and you're going to practice in exercise 2E to do this, but I'm not interested in this. Why? Because you can all learn this. This is methodical. You can look at the examples, you can do it over and over, and you'll get it. The difference is whether you understand the concept. What was the concept? Right here. That's the key step here. And the key step I just said is if A inverse exists, X will exist. So the question is, how do I know when A inverse will exist? And what does it mean when you say X will exist? That's the key step. Okay, so you can copy these methodic sort of method to sort of solve the problem. But that's what I really want you to think about in this session. Okay, so by the end of this session, what you're going to try to understand is what do I mean when I say A inverse must exist? And when it does exist, what does it mean when X will exist? Okay? All right, now let's just have a look, just a brief look at our formula. This is my A inverse. I said only if A inverse will exist. How is it possible for this not to exist? Yes, Josh? Yeah. And this is why, if you remember, I told you to copy the very first slide. I said determinant of A does not equal to 0. And I said that was what I was telling you. You won't have to memorize this because it makes sense. Why can that not equal to 0 if you want to have an inverse? Because I said inverse will exist if determinant of A is not equal to 0. And that makes sense. Because if it's equal to 0, you can't have 1 divided by 0. It's undefined, so it makes sense. So you don't have to memorize this property because it makes sense if you understand the inverse. Okay? So the inverse can only exist as long as determinant of A doesn't equal 0. So you're like, all right, cool, that makes sense. Now here's the next question. What is the inverse? What is the purpose of doing the inverse? We wanted to find x. But what is x? So why did we want to know what x is? Okay, and this is what I'm going to get you to understand here. We're going to move on. What are you really doing? So I just showed you over here. So we've got 2. We've multiplied A times x gives you B. Okay, I've done all this mathematics here, and it's A inverse. It's really crucial. If it exists, you get x. Okay? What is x? Now, I want to quickly show you here. When you multiply all this and you simplify it down, you get this. This is what I want you to think about. Matrix A, 2, 2, negative 1, 1, times x, which is xy. I'm using xy to refer back to your memory on what you learnt in year 9. And then b gives you an answer of negative 4, 4. Okay? When you're solving for this, it gives you negative 3, 1. In fact, what matrix x is representing is the coordinates of an intersection. I'm going to write that down. I want you to write that down too. So the x, this actually means the coordinates of an intersection. Now you're questioning, you're like, well, what intersection are you talking about, sir? And let me show you. We just said this is matrix A. Yeah? This is matrix A. This is matrix X. This is B. True? If we use multiplication of matrices that you just learned or revised, row 1 times column 1, what you're going to get is you're going to get 2 times x plus 2 times y equals 2, negative 4. Let's write that down. So I just said 2 times x plus 2 times y equals negative 4. Now, if I wrote that out, what does this look like to you? 2x plus 2y equals negative 4. What does that remind you of? What kind of graph is that? It's a linear. It's a straight line. This is, matrices is only dealing with linear equations. So, you've got a linear equation. What's the bottom one then? Negative 1, 1 times xy. If you do it row 2 times column 1, you're going to get this one. Negative x plus 1y equals 4. That's another linear equation. Now, if I taught you, if I got you to remember back into year 9, you got 2 linear equations, and I told you to simultaneous. Okay, you use elimination method or substitution method. This is what you're going to get. I'm using elimination method here. I'm using this by 2, times this by 2, times this by 2, and you get negative 2x plus 2y equals 8. But I want you to see this. See, when I solve for it, this equals negative 3. What is that representing? Let's have a look. I'm circling it. That's where my negative 3 is. I've just done year 9 mathematics here, simultaneous equations. So the question is, what is matrix, solving matrices, what are you really doing when you're solving for matrix X? It is finding the coordinates of 2 straight lines. That's all it is. You got 2 straight lines. This is equation 1, straight line 2. You're finding the x and y coordinate for the intersection of 2 lines. Which is why last year, if you think about it, it was unique solution, infinite solution, or no solution. How's that possible? Think about it. If you got 2 straight lines, if I'm just going to go back a bit so we got a bit more space. Think about it. 2 straight lines. If you got 2 parallel lines, would that ever intersect? No. So we say that's no solution. If I then had 2 lines that cross, How many solutions or how many intercepts do I have? One. It's one intercept right there. And that's why we say unique solution. And then what's infinite solution? Infinite solution basically means this. You have the exact same line. That's why you have infinitely many different solutions. So it'd be like saying solve x equals x. If I did x equals x and I said solve it for me. It could have been 1, 1, could have been 0, 0, could have been 2, 2. That's why you can't solve this. Because if I minus x on both sides, you just get, that's why you can't solve it. Same thing if it's parallel. So what's parallel? Let's say parallel lines, we said no solutions, right? No solutions. Let's try this. If I gave you 3x plus 1 equals 3x minus 2. If I told you to solve this equation using year 9 mathematics, you'd say subtract 3x on both sides, and then suddenly, it's not solvable. You got 1 equals negative 2. That's why we say no solution, unique solution, infinite solutions. There's only 3 scenarios that you can draw with 2 straight lines, how they intersect. So what are you doing when you're finding the inverse? I just said again, when you're finding the inverse and x exists, all that means is you have a coordinate of intersection. If you have a coordinate intersection, it means you can solve. So that's why, right at this step here, I said the key step is right here. If you can get this step, this means it is possible to solve. So why do you want to be able to solve it? Because that means there is a coordinate. It means, yes, there is an answer where they both intersect. But if it's not possible to find your inverse, that means it's not possible to find a coordinate of intersection. And because you don't have a coordinate of intersection, it's either parallel or infinite. It's very logical. You see, we're just saying if this exists, it means it's solvable. If it's solvable, you get an answer. If it's not solvable, well, the only 2 possible solutions that you're going to get, that's when it's not solvable. And when you have 2 of the same lines, that's when it's not solvable. That's what it means. So that's why when they say if an inverse exists, the determinant, what is it? Determinant det of A cannot equal to 0. That's all they're trying to say. They're just trying to say if the determinant is equal to 0, obviously you don't have a solution. If you don't have a solution, there is no intersection. Or it's not possible to solve. The only time you can't solve it is when you have parallels and you have the same line. Logically, that's what I showed you over here. Does that sort of, I know it's quite a bit, but does that make some sense? Okay, so let's repeat after me. Let's repeat after me, just so I know that it's ingrained in your head. What's the determinant of A tell you? It tells you if the inverse exists. Okay, repeat after me. If the determinant of A equals to 0, it means inverse does not exist. Okay, so let's say it again. Inverse doesn't exist. Go. Good. Inverse doesn't exist when? When? Say when. Good. Determinant equals 0. Alright, I'm going to say it again. When determinant equals 0, the inverse does not exist. Okay? If the inverse doesn't exist, now here's the next question. If inverse doesn't exist, going to say it again. If inverse doesn't exist, x doesn't exist. Okay, so if inverse doesn't exist, say it. I'm going to grain in your head. If inverse doesn't exist, x doesn't exist. Okay, do it again, once more. Then, okay, but now my next question is, what does it mean when x doesn't exist? No, don't repeat after me, I'm just asking now. I'm asking now, think about it. When inverse doesn't exist, what does it mean when you say x doesn't exist? That's what you just repeated after me. What does it mean if this doesn't exist, x doesn't exist? There is? Yeah, there's no intersection. Now, which cases will you not have an intersection of two straight lines? When it's parallel and infinite solutions. Now, I know you're like, but infinite solutions do intersect. Yes, they do, but it's not solvable. See, if I gave you 3x equals 3x and I said, all right, go find x for me, you're not going to be able to solve that. That's why when inverse doesn't exist, okay, then I'll say it again. When inverse doesn't exist, x doesn't exist. Okay, I'm going to say it again. I want to hear everyone say it. When inverse doesn't exist, x doesn't exist. Okay, now trick question again. What does it mean when x doesn't exist? No solutions, no intersections, not solvable. That's all it is. If this doesn't work, you can't solve it. If you can't solve it, there's only two straight lines that can't be solved. Parallel, infinite solutions. Okay, now, you know what I just realized? That's being recorded. So, to whoever's listening to this again, they must be like, I think I got this now. All right, here we go. What I just did with you, listening. What I just did with you is an explanation when the determinant equals to 0, inverse doesn't exist. And you just told me when inverse doesn't exist, then x doesn't exist. And the only times x don't exist is when you have parallel lines and infinite lines. Okay? So that's all I'm trying to say there. Now, and this last slide, it's up to you whether you want to look at it. But the question is, I'm just giving an example here. You've got matrix A multiplied to matrix X. You don't have to copy this. This is on the PowerPoint. Equals to matrix B. This is all we've been doing. This is where the formula comes from for your inverse. So if you're wondering where your inverse formula comes from, it comes from here. We're saying we need something to multiply to A to get rid of that A. So this is what they did. They said, all right, let's just multiply these values here. It expands into this. And what we want is we want A, and we want this to the inverse. That's what we want. So the red colored is your inverse. This is your identity matrix. If we can make this true, we find a formula for your inverse. And that's how it works. If you did row 1, column 1, you get this second matrix here. Now, the nice thing is you get equations. Look, you can say this position has to equal to that position. That's why you can say AX plus BU equals 1. You can say AY plus BV equals 0. If you follow this, you get 4 different equations and you got 4 unknowns. So you can simultaneous each one, and all I've done here is I've shown you how to simultaneous it. And what you're going to get is you get what x equals to. Okay, so I've just done simultaneous to find out what x equals to, and that's what x equals to. So you see how I did here, you've got ax plus bu equals 1, which is this first equation over here. And then I got cx plus du equals 0, which is this equation over here. I simultaneous those two using elimination method. Took out x as a common factor, literal equations, chapter 2, exercise 2B. I find out x. Now if you do the same thing for the second side, you get y, and you do the same thing again for u, and you do the same thing again for v. This is what you get. X equals this, y equals this, u equals this, and v equals this. And that's why when you take a common factor of 1 on AD minus BC, you get D minus B minus C, A. This is where your inverse is coming from, because they were trying to prove this. This is all they were trying to prove. They were just trying to say, this is matrix A. If you multiply by something, I want it to equal to 1, 0, 0, 1. And that's the theory. Okay, so let's go back to the theory. Same thing again. You're going to repeat after me until your head is totally into this idea, okay? Let's go back. Here we go. All right, here we go. Let's repeat again. AX equals B, okay? I'm just going to get to this part here. If A inverse does not exist, okay, repeat after me, then X doesn't exist. Good. Let's do it again. If A inverse doesn't exist, then X doesn't exist. But what does it mean when X doesn't exist? No solutions. When will you have no solutions? Paralline and infinite. Now, take a step back. When will A inverse not exist? Good. When determinant equals 0, inverse doesn't exist. And when inverse doesn't exist, then X doesn't exist. If X doesn't exist, no solutions. And the only two scenarios, parallel lines and infinite lines. That's your theory. That's the concept. I want you to practice exercise 2E. Okay? There we go. That's how easy it is. Chapter 2 is all that. That's it. That's the concept for chapter 2. You got that? That ties everything up. Okay? 2E, 2F, 2G. It's all the same thing. Yes, you can. Alright, exercise 2E. I'm going to upload this video.